Hey, we're back with another wonderful lesson, our last log lesson. Before we start, I just want to remind you that I have a YouTube channel. It is beautiful, and I have started doing these 10-minute math reviews. Sorry, I don't know, I forgot I'm wearing this weird little hat thing. I'm cold today. So, yes, we got 10-minute math reviews. Give me suggestions for topics. My intention is to eventually cover every topic or concept in grade 12 pre-calc. Just in 10 minutes or less, with a focus on the Manitoba curriculum, but I can do them in any order you like, so any suggestions, leave a comment below. Let us begin our lesson today on applications of exponential functions. So we're going to be seeing a couple of the wordy problems that show up on the exam, and you will remember way back at the beginning of the unit, we were doing questions that involved compound interest here. So this formula you've seen before, just a reminder of what everything is here. Let's try a couple of these questions. Back in the day, we had to graph these to actually figure out the answer if our unknown was in the exponent. So now that we sort of know about logs and log laws, we can just use logarithms to solve these more complicated equations. So, you would have done a question like this back in the day. $5,000 is invested at this interest rate. Don't forget that you need to convert it to a decimal. Okay, so this is 5.75. You're going to divide by 100, and then you're going to be using 0.075 as the rate in the question. Now, compounding quarterly, so that's the end value. So n value is going to be 4. Find its future value in 7 years. So we know that 7 is t. Remember, this is the formula that we're using. So that's 1 plus r over n to the power of n times t. The thing is that, let's see, well, this is just a regular one. Finding the future value is just finding the value of a. So we know that the initial value here, p, that's the principal, 5,000. That's invested at a rate of 5.75. So we're going to go 1 plus r 0.0575 divided by the compounding period's 4 raised to the power of n times t, so 4 times 7. Now you can pop that in on your calculator, right? I recommend you do it in a variety of steps. So first figure out what you get inside the brackets, then raise it to the power of 28, hit equals, then multiply it by 5,000. You can pause the video for a moment, but if you do that all correct on your calculator, you're going to get 7,456.40. Yay, what a great way to invest your money for 7 years. Oh, right. Well, what about B? How long would it take to double in value? Now, this is an interesting question because it shows up on the exam sometimes. They don't need to tell you the original amount, okay? If it's going to double in value, then you know, so here's your formula. So in this case, we know the original amount is 5,000, but I'm going to show you the sneaky way to do this. So normally, the double of 5,000 would be 10,000, okay? So I'm going to just ignore all the other variables for a second. At some point, you're going to be dividing both sides by p, right? So it's saying how long will it take? So we're looking for t. Okay, so we're looking for the thing in the exponent. Now remember, we know n is 4, and we know what r is at 0.0575. So this is a question that we couldn't solve before because we didn't know our log laws yet. Well, I just want to point out that the ratio of a to p is going to be 2, right? So when you divide both sides by the 5,000s, I'm going to go and pop in all the other numbers here. So I'm just popping in all the numbers I know. So it's going to be 4 times t, so 4t. Okay, I'm going to be solving for this. We're going to use logs. So like I said, we're going to have to divide both sides by 5,000. When you do that, 10,000 divided by 5,000 is 2, and you're just going to have all of this left over. So we're not really going to do anything with this stuff in the brackets just yet, so I'm just going to kind of recopy it. It's going to get pretty ugly. Okay, but I'm just going to leave it right here and say, okay, so now you're solving this equation. You're going to have to apply log to both sides because you need to use the power law to bring down the thing that has your variable in it. So I'm actually going to apply ln, the natural log. I prefer to do that. It's one less letter. So instead of using log, I'm going to use ln. Now that I've applied ln to both sides, I can use the power law to move the 4t down in front. So I'm going to have 4t times ln of all this stuff, which I still am not going to type into my calculator. Okay, and that's equal to ln 2. I'm trying to solve for t, so I'm going to divide both sides by 4, right, to get rid of the 4, and also this thing, the thing that has the ln. So it's really messy, but I'm going to divide both sides by that. So over here, ln 1 plus 0.0575 divided by 4. Perfect. Whatever I get on the left-hand side is going to be t. So if you type this in on your calculator, be very careful when you do it. Make sure you use brackets. You're going to get 12.14 years. Now, I don't remember if the question, it didn't give a time frame, like how many decimals to round to. So on the exam, they say round to 3 decimals unless otherwise noted. So unfortunately, I didn't do that in my notes. But anyways, that's how you would do that question. So on to the next one. This is a very similar question. The only thing, so it says a sum of money is invested at 8%, compounding monthly. So this would be R. So divide by 100, you get 0.08. Compounding monthly means n is 12. Now we don't know how much money this is. So basically, we don't know the principal. How long will it take to triple in value? Okay, so I'm just pointing out here, you don't actually need to know how much A is or how much P is, right? We know that the ratio when you go A divided by P needs to be 3, okay? So if I invested $1,000, my final amount would be 3,000. A divided by P would be 3. So you don't actually need to know them. What they're doing here on this question is getting you to realize, hey, I take this formula, and I know that when I go A divided by P, I get 3. So now you're going to solve 3 equals what's left over, 1 plus that stuff, right? We divided P into A and we got 3. So I'm going to just quickly pop in the numbers. You should pause the video at this point and try it out on your own, because at this point it's the same as the other question. So here we go. And what do we got? We got 1 plus 0.08, n was 12, then we got 12t. You're going to apply ln to both sides, so you can use your power law. Bring that down. At the end of the day, when you're all done, you're going to get ln3 equals t, and I'm just doing some quick work here, so I would have brought the 12t down, and then I would have divided by 12 times ln of all this stuff. Exactly the same process as the other questions. So you can go back and look at that one if you're stuck. When you type that in, I get 13.78 years. Again, I should be rounding to 3 decimals, but I'm not. There we go. All right. Okay. On your exam, you might have a couple questions about pH. So you might know from chemistry class like what pH is. If you don't, I just briefly defined it here. So it's just like when you have a solution, it's the negative logarithm of the number of H plus ions in a solution, okay? So basically, mathematically, your pH is equal to negative log of those positive hydrogen ions or whatever, blah, 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 blah. Yes. Power of hydrogen ion concentration, P is for power, and H is for the H plus ion, so that's where the word pH comes from. You know what, you can probably read this through on your own. One thing that you do need to know, it's a scale from 0 to 14. And every time you go up by 1, the concentration increases by a factor of 10. Okay, so if I have a solution that has a pH of 6, and then I look at a solution of pH of 7, the solution of pH of 7 is 10 times more concentrated, has 10 times more H plus ions as the one of pH 6. So what this means for us is sometimes on the exam you get questions like this, like how many times more acidic is an acid with a pH of 9 versus a pH of 6? Well, it's just a log scale of 10, okay? So first you figure out the difference between 9 and 6, which is 3, and then each pH level is 10 times more acidic. So you simply take 10 raised to the power of 3, and you figure out, hey, a pH of 9 is 1,000 times more acidic than a pH of 6. Every once in a while you get one of those in the exam. Sometimes you get Richter scale questions. Richter scale is just again, a log scale that measures how intense an earthquake is, okay? So sometimes you get one of those. Yes, an earthquake of Richter scale 2 is 10 times more powerful than an earthquake of Richter scale 1. So again, we have a base 10 kind of thing. So I got this question here. In 1906, San Francisco earthquake had a magnitude of 8.3. At the same time, in South America, there was an earthquake with a magnitude of 4.1 that caused only minor damage. How many times more intense was the San Francisco earthquake than the South American one? Well, this is very similar to the pH question. First, we need to find the difference. So find the difference in magnitude. So I'm just going to go like that. So the difference in magnitude, well, one of them had a magnitude of 8.3, the other one had a magnitude of 4.1, so you're going to get 4.2 as the difference, okay? So what does that mean? Well, therefore, the San Francisco earthquake was, now remember, this is a log scale, so you go 10 raised to the power of the magnitude difference. It was 10 to the power of 4.2 times more intense than the South American earthquake. All right, and if you want to type this in on your calculator, just to give you an idea, you get 15,849. So it was almost 16,000 times more intense. Wow! All right, last Richter scale question. Every once in a while you get one that looks like this. This is about as tricky as they get. So let's see. In 1985, Mexico City had an earthquake with a magnitude of 8.1 on the Richter scale. Let's see. In 1976, an earthquake in, I'm going to say this wrong probably, but Tangshan, China, was 1.26 times as intense. What was the magnitude of the Tangshan earthquake? Wow. Okay. Well, you're going to need to define a variable for this one. So you're going to say let x be the magnitude of the Tangshan earthquake. We have the Richter scale value for this one, but we have how many times more intense the one in China was. So we have to set up our equation like this. The one in Tangshan was more intense. We're going to say x minus 8.1, which is the magnitude. We know that the difference was 1.26, okay? So this is kind of like the last question we did, but this time we don't know what that number is, okay? Usually we knew this one and this one, and we found that one. Now we know the difference between them. We know the magnitude of one, but not the magnitude of the other, all right? Then you got to set up your equation. So you know that 10 to the power of x minus 8.1, that needs to equal 1.26, okay? Now the only way you're going to solve this equation is by applying logs. So you're going to apply log to both sides, so log of all this stuff and log of that. And now you can use the power law to bring the x minus 8.1 down in front of the log 10. And then on this side, you just got log 1.26. So it's looking good. Now, you can actually evaluate log 10, right? So log 10 is just 1, because the base is 10, the argument is 10. So that's actually just 1. So you have 1 times x minus 8.1. Those are being multiplied together. We're almost done. So 1 times anything is just itself. So you're going to have x minus 8.1. You're going to add 8.1 to both sides. So you're going to have x is equal to what? Log 1.26 plus 8.1. Now when you type this one in on your calculator, you're going to get 0.1. So you get that x is 8.2. There it is. So what does that mean? It means and again, I'm probably saying this wrong, the Tangshan earthquake was 8.2 on the Richter scale. All right. Now, I don't want to worry you too much. Sometimes you get these questions on the exam, sometimes you don't. It's pretty hit and miss. I'd say it's about 50% of the times or so, 40%. No. All right. The questions that you do tend to get a lot of are the ones that have the formula of natural growth and decay. So you're going to remember this one. You're going to recognize this formula as the compound interest formula that we were just using. But when we do natural growth and decay, basically the growth is almost continuous. So long story short, we do a limit in here. So we do the limit of this. You're going to recognize this as the limit that gave us Euler's number, E, okay? So when you do this limit and you take x to infinity, you end up getting this formula here. So we basically replace this chunk of the formula with the natural number E. So that's actually Euler's number from the other day. Okay, so this you'll have to remember, A equals pert, P times E raised to the power of R R times T. That's called the natural growth and decay formula. Let's use it. Let's compare some questions first. So let's see. Let's not do this. Let's not do this because there's hardly a difference. So we'll skip this slide. I apologize. I should have removed it. Let's just get right to using the formula. So these are the kind of questions you're going to see on growth and decay. So if you want to write growth decay questions, then that would be great. Take a moment to read that while I struggle to flip to my page. Here we go. So, how do you know that there's going to be a continuous growth and decay type question? Sometimes the exam will just tell you that it is. It'll say, hey, use this formula. Otherwise, it'll have to do with bacteria, okay, something like that. So, currently there's 100 bacteria in a petri dish. So, in my formula here, A equals P E raised to the power of RT. P is 100. The rate of growth is 2.5% per hour. And then they say, how many will there be after 1 day? Well, you need to make sure that your rate, if it's in hours, that your time frame is also in hours. So there are 24 hours per day, okay? So time is going to be 24. The rate we need to divide by 100, so we're going to get 0.025, and we have everything we need. So how many will be there in a day? Well, A equals 100 times E raised to the power of R, which is 0.025, times T, which is 24. Now you pop that in on your calculator however you like, and you're going to get 182 bacteria. Excellent. How long will it take the population to double? Well, if the original population is 100, then the final population will be 200, and everything else stays the same. So we're going to go 200 equals 100 E. The rate is 0.025, and we don't know T, right? They're saying how long will it take to double? We are going to have to apply logs. Now, apply ln. Right? Anytime you have the natural number E, you're going to want to use ln. Just remember that property that ln E is 1, right? Okay? So we'll be able to cancel that out. So let's see. Apply ln to both sides. Before you do that, you could divide both sides by 100 to make the question a little bit easier. So you're going to get 2 equals E, 0.025 times T. And it's like, okay, apply ln to both sides. There we go. Now we can use the power law to bring this down in front. 0.025 times T times ln E, that equals ln2. Well, we know ln E is 1. Okay, it's just a fact you're going to want to remember. These usually show up on the non-calculator part. Sometimes, not always. But anyways, divide both sides by 0.025. So you're going to have ln2 divided by 0.025. That equals T. When you pop it in on your calculator, you get 27.7 hours. Don't forget your units or you'll lose half a mark. All right, we're making great time. Sometimes you get questions, that was a growth question. Sometimes you get questions that have to do with decay. Now, if it's a decay question, your rate is negative, and that's the thing you need to remember. So it says it decays. So you got a radioactive solution decaying at a daily rate of 3%. So when you find your rate, remember it's going to be negative 0.03, right? So divide that by 100, throw a negative in front. And that's basically the tricky part of this question. So it says you start with 80 grams. So that's P. How much is left after 1 week? Now, again, be careful. They gave us a daily rate and they gave us the time in weeks. They have to match. So how many days are in a week? It's 7 days, and that's equal to time, okay? So that's another tricky thing they do. They like to mess with the units. So you know you're just using this formula, okay? So we are looking for how much is left over, so that's A. We started with 80. E raised to the negative 0.03 times 7. Pop that in on your calculator, and you will get an answer of 64.85 grams. Great. Now, what is the half-life? So sometimes you need to know what this word half-life means. So half-life means, you might be able to guess this one, but half-life means when there's half of the substance left over. So when half of the original substance is left over. So they'll expect you to know what the word half-life means. So, well, half of the original substance, so that means that when we take this formula and we divide both sides by p, and we're stuck here, that means that this ratio is 1/2. Okay, so you've got to modify your formula in that way, and now you can plug in the numbers you know. So I'm going to write 1/2 as 0.5 now. And I know that I'm going to need to apply ln, but I'm just going to wait a second. So my rate was negative 0.03, and I was looking for the time it takes for the half-life to happen. So I need to solve this equation. I'm going to apply ln to both sides. So ln of this and ln of that. I can use the power law to bring that down in front. So I got negative 0.03t times ln e, and I have that is equal to ln 0.5. Now, that's 1. Divide both sides by negative 0.03. So you're going to get ln 0.5 divided by negative 0.03. That's equal to t. Pop it in on your calculator, and you're going to get 23.1 days. Again, don't forget the units at the end. Well, that was a blast. Excellent. I think I can almost leave you there. This is just another question that is exactly the same with different numbers, slightly different wording. So I'm just going to give you the answer to it. I will point out that it says it loses 0.8%. So that's how you know it's a decay question. So the wording is slightly different. Just remember, you divide that by 100 and throw a negative in front. So you're going to be using that number there as your rate. Notice that the time frame is in years. And it says find its half-life. Again, you don't need the initial amount, right? Because you know that A divided by P in that formula is going to be 1/2. Okay, so you set up your equation. When you do all the work, using the numbers I gave you, same procedure as last time, you're going to get 86.6 years. So try it out yourself. Pause the video, do that. I'm going to skip this one. It's just an extra question. We don't need it. I didn't even bother doing it in my notes. All right, there's one last question here with gophers. I don't know if we need to do this one. What are they asking here? There's 500 gophers on day 1 of an experiment. By day 20, the population has risen to 800. How many gophers should there be by day 28? Okay, maybe we will do this one. So yeah, it's a 2-step question because you don't know the rate of growth. Okay, so the first step is find the rate of growth. And you're going to be using this formula. Anytime it has to do with bacteria, things that are living, this is generally the formula we use. So yeah, let's go ahead and let's do it. So we know that 800 is A. We started with 500. And we know that after 20 days, we got to 800. So this is time. So in this formula, pop in 800, 500 for PE, and we don't know the rate, but we know that T is 20. Okay, so you're going to have to apply ln to both sides. Before you do that, you could divide both sides by 500 just to make the question a little bit easier. Now 800 divided by 500 is 1.6. So you get this. And then I'm just going to go 20 times r instead of r times 20. Now apply ln to both sides. So you can use the power law, bring that down in front. We know that ln e is 1, so I'm just going to write that. Right, well here, I'll throw it in there, ln e. We did the power law. That cancels out to 1. You don't want to confuse anyone. Now divide both sides by 20. And for r, I don't think I actually wrote down what r is. I'll just quickly grab my calculator. I I mean, that's what you're going to be popping into your calculator. Now, my calculator is very faded. The buttons are... So much math has happened on these buttons. Where's ln? ln 1.6 divided by 20. Okay, so you get 0.0235 equals the rate. So that would be step one. Now, what do they want? They want to know how many gophers will there be by day 28. Okay, well, now that you know your rate, you can go pop it into this formula. You started with 500 gophers. You know it's E. The rate is 0.0235 and 28 days. Okay, so you pop that in on your calculator. If I did everything correct, I got 965 gophers. Get out to here, you gophers. There. Wonder bar. Woo! That was wonderful. Oh, we are done this unit. This was a hard unit. So, thanks for sticking with it. Check out the supplementary questions. I'll post them. Maybe I'll put a link in the description of the video as well. And study up hard because we got our testorino coming. Yay! See you next time, everybody. Bye-bye.